So for page 93, call it solving logarithmic equations. And you're going to paste your foldable onto this page. And so this has a flow chart like you had yesterday for solving exponential equations. And so the question, you look to see if all of the terms have a log term. If they do, then we will follow these two steps. However, if they don't, then you'll follow these three steps. So here's an example of each. So yes, if every single one has a log term. So looking at this equation, you're trying to figure out what x you can plug in here such that log base 5 of x plus log base 5 of 3 is equal to log base 5 of 27. So number one says to condense both sides of the equal side. So on the left-hand side, we'll condense this into a single log. In order to do that, we will multiply 3 by x and have log base 5 of 3x on the left. On the right-hand side, we'll have log base 5 of 27. So you'll notice that the logs are now the exact same on both sides. They have the same base, which allows you to be able to set the arguments equal to each other. So we have 3x equal to 27. You'll divide both sides by 3, which gives you x equals 9. So if you plug that back here into the original, you'll have log base 5 of 9 plus log base 5 of 3 equal to log base 5 of 27, which is a true statement using your properties of log to put that back together as 3 times 9 is 27. If, however, all of the terms do not have a log in them, we'll do step 1, which says get all the logs on the same side. That means the other things that don't have a log will go to the opposite side. Number 2, we'll condense the logs. And then once you've condensed them, you'll do number 3, which means to turn it into, which is to turn it into exponential form, and then solve for x from there. So here's an example. You'll notice that this 3 right here does not have a log term. So we'll move it to the right by adding. However, this term right here does have a log, so we'll move it to the left by subtraction. And so now we have log base 3 of 4x minus log base 3 of 5, which is equal to 3. Condense this expression with the minus now. We're going to divide the two arguments. And so we have a single log base 3. We'll take the first argument, 4x, and divide it by 5, and that's now set equal to 3. This is the logarithmic form now. It's been condensed into one log equal to a number. So now we're going to do step 3. We're going to turn this into its exponential form. So in order to do that, it looks like these bases should have been 2. All right, do me a favor. Go back and change these 3's right here to 2. So I apologize for the confusion. So if we come and look at this right here, this says 2 to the 3rd power. So I made a mistake in my page, so I'm sorry about that. So this is going to be 2, a log base 2 now. So we have 2 for the base, 3 is the exponent, so 2 to the 3rd power equal to 4x over 5. 2 cubed is 8, so we have 8 equal to 4x over 5. And then we'll multiply both sides by 5 to get 4x equals 40, and then we'll divide both sides by 10 to get x equals 10. And so if you were to plug that back into the original, 4 times 10 is 40. So if you were to condense this into a single log, we've had 40 divided by 5, which is log base 3 of 8. Log base 2 of 8, which truly is 3. Okay? And then the last thing we want to do once we find our answers, when you're plugging back in, it's very, very important that you check things because you can pick up an extraneous solution. So if when you go to put these back into the original problems, if any of your logs have a negative argument, you have to get rid of it. It's an extraneous solution. But as long as your logs are positive, then you should be fine and your answers should check out. And that's it for this page.